Interstellar Mapping and Acceleration Probe, or IMAP, Sensor Lead on the Interstellar Boundary Explorer, or IBEX, the Instrument Lead on the Magnetospheric Multiscale Mission, or MMS, and Deputy Principal Investigator and Instrument Lead on the Tandem Reconnection and Cuss Electrodynamics Reconnaissance Satellites. Don't say we don't have acronyms. Tracers, because that makes sense. Dr. Fuselier got recruited to Texas in 2011 to work with SWIRI after 25 years at what is now Lockheed Martin Advanced Technology Center. He's well known for his fundamental contributions to the understanding of physics, interactions between solar wind and the Earth's magnetosphere, comets, and the interstellar medium. His scientific interests include analysis of space plasma and energetic neutral atom data from various spacecrafts, including, there's like several ICE ones. They all have E's because they're explorers, but a lot of different missions. He was elected to the National Academy of Sciences for his achievements in original research in 2021, and now he serves as adjunct professor at UTSA, where he gets to collaborate and mentor early career researchers in his field of space physics. And recently, from 2022 to 2024, he served as co-chair for the Solar and Space Physics Decadal Survey. The survey is now published and describes what the community wants to do over the next decade, and that is a significant undertaking in itself. But let's give it up for Dr. Fuselier. Oh, for the room, and especially for the first timers out tonight, we have a drinking word. What that means is when that word is uttered, what do? And we take a drink. What is your drinking word tonight?
Exoplanet.
Drink responsibly.
All right, thanks. As Adam just said, I spent the last 2 years plus working on a decadal survey. And in fact, if you want to download a copy of it, there's a QR code right there. You can get your own copy of it, all 957 pages of it. Working on a decadal survey, you get to work on a lot of different things and work with a lot of very smart people. And one of the things that we had in a decadal was this quote here, that the heliosphere, which is the home of our star and our planet, and I'll explain the heliosphere in a minute here, remains the only habitable system that we know of in the universe. And it sounds like a rather bold statement, but I think I'm going to back that up. So you've all seen the headlines. In fact, just driving home tonight, I heard about another exoplanet that was discovered. Here's one. It's called TRAPPIST-1e. It's an Earth-sized exoplanet, 40 light years away, orbiting an ultra-cool dwarf star. Now, wouldn't you like to orbit an ultra-cool star? Yeah. I think by the end of this talk, the answer is going to be no. Anyway, it resides in the star's habitable zone, and it's a prime target for studying potential habitability and searching for life. And here's the artist's conception of this TRAPPIST-1e, and I think that's some nice beachfront property there. I'd like to buy it and live there. So what does it mean to be habitable? And so what I'm going to do is spend the remainder of my talk focusing on one element of habitability. It's an element that you don't usually hear about, and that's called radiation exposure. And we're going to use our own solar system because we know that this is the only known habitable system to look at radiation exposure and what it means to be habitable. So solar and space physics, we love line plots, and so, so I'm going to give you one here, but bear with me because it is quite a nice plot that shows the competition in the radiation world between the sun and the solar output and the galaxy and cosmic rays. So Voyager 1 and 2 were launched in 1977. They're still operating. I blanked out the rest of this plot. You'll get to see it in just a minute. But what I wanted to do was show the plot for Voyager 1 when they were launched in 1 AU, so 1 astronomical unit away. That's commonly known as Earth orbit. And they proceeded out and eventually left the heliosphere. But you can see that as a function of time, and it carries an instrument on it, among other things. It's a cosmic ray detector, and this is a plot of 70 MeV per nucleon cosmic ray fluxes in counts per second. That means a whole lot of things, but basically think a Geiger tube, you know, they go around and beep, 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 right? It's a little bit more sophisticated than that, but not much. And they measure basically the cosmic ray flux as a function of time and distance from the sun. And you can see that it's modulated, it goes up and down. And if you take the distance between these two troughs or the two peaks there, that's 11 years. Now that should be familiar because that's a solar cycle. And so what you're seeing is a competition between the incoming cosmic rays from the galaxy and the solar output in the form of the solar wind and CMEs and things like that, that is basically reducing the cosmic ray flux. And so actually these dips are not occurring at solar maximum, they're occurring at the declining phase of the solar cycle because that's the time when you have the most CMEs and energetic effects from the sun. Okay, so you've probably read this quote by now. If you go outside of Earth orbit in 1 year, 1/3 of your DNA will be hit by a cosmic ray. So that's been outside of the Earth's protective magnetic field. So the astronauts on the space station, they're okay. They're inside the Earth's magnetic field. But we do have examples of people who have left the Earth's protective magnetic field. That's the 18 Apollo astronauts. And all 18 of them had to have cataract surgery. And the reason for that was that on their way to the moon, they left the Earth's orbit for basically up to a week, 3 days to a week. And on the way to and from the moon, when they were orbiting the moon, they were complaining about seeing flashes of light. And those flashes of light are a cosmic ray that's going through their eyeball and creating what's called Cherenkov radiation as it propagates through the eyeball. And there's various stories about how they discovered that this was happening, which if you ask me about it, I'll tell you about it. So the idea, though, is that you can see that if you want to go to Mars, you would probably go just after solar max because the cosmic ray flux is down by a factor of 2. Okay? And so it seems almost counterintuitive, but you can reduce the cosmic ray flux by using the sun's output. Now, you have to worry about solar flares, but hey, you roll the dice and take your chances. Habitability, what you want is you want low solar activity, and you want an effective shield for that activity. The effective shield is the Earth's magnetic field, and it basically protects us from the large, significant flux from the sun It does a pretty good job of that. And it also reduces the cosmic ray flux. And so as long as you stay within that magnetic field, you're pretty good. You need what's called the magnetosphere, and it's a planet with a relatively strong magnetic field. You don't want it to be too strong because then you'll end up with something like Jupiter, where the internal radiation belts at Jupiter make it the worst place in the solar system to visit. And so you want a magnetosphere, you want a relatively strong magnetic field, but you don't want it to be too strong. So you can see you're starting to get into a balance of things, when you start talking about habitability. Now, the thing you don't want is a dwarf star, like the star that's the central star for TRAPPIST-1e, because they tend to be the producers of the strongest known stellar flares, 1,000 times stronger than the sun's strongest flares that have been observed. And so the last thing you want is to be on a planet that is orbiting a K or M star, as that is a relatively small star like the TRAPPIST system. And I'm going to give you another reason for not being in orbit around that star right now. Okay, so this is the rest of this plot. All right, so you saw this. This is when Voyager was inside what we call the heliosphere. This is a protective bubble that is inflated by the sun's magnetic field and solar wind, and it extends out to about 150 astronomical units, 120 in this case, and you can see that the cosmic ray flux was fairly low here as you approached this termination shock. That's actually where the solar wind goes from supersonic to subsonic. And then when you got to the heliopause, that's where the solar wind can no longer propagate into the interstellar medium because the interstellar medium is basically blocking the way. And you can see what happens to this cosmic ray flux is that it rises and then it just basically flatlines. And the reason why it flatlines is that you're now out in the galactic medium, in an interstellar medium, and you're seeing the cosmic ray flux that as if you did not have the protection of the heliosphere around you. And so you want to do interstellar travel. Well, before you get 1,000th of the way to the nearest star, your cosmic ray flux goes up by a factor of 5. Now, remember what I told you, it's over there, just 1 year outside of the Earth's magnetic field, and 1/3 of your DNA is hit by a cosmic ray, as hit by cosmic rays. Well, that's close to the sun. That's back here where Voyager started out. Okay, when you get out here, cosmic ray flux factor of 5 higher. And so what you want is you want a stellar magnetic field and a stellar wind that's fairly strong that can inflate this bubble that basically keeps the cosmic ray flux at bay to a reasonable extent. And that is not going to happen around a K and M star. So an exoplanet that's surrounded, that's orbiting around a K or M star that is a relatively weak star, an ultra-cool star, doesn't have this heliosphere to protect it from the cosmic ray flux. So you put it all together, and you can see that it is very complicated. So just on the radiation exposure concerns, you want a stellar magnetic field. You don't want it weak because you have a small stellar sphere and you don't have the cosmic ray shield. You want it moderate, like the sun. You have a large stellar sphere and a cosmic ray shield. And this is kind of a, oh, that was bad. Yeah. Don't do that. Yeah. This is just an artist's conception of here. This is the termination shock and the heliopause out at 150 astronomical units. But by the way, Pluto, 40 astronomical units, so this is significantly further away than the planets are. Stellar activity, you want it low. The sun is actually, the activity on the sun is decreasing, and it's actually, in terms of F and G stars, it's a relatively inactive star compared to other F and G stars. You don't want it high because you get these extinction level flares. And remember, if you want habitability and you want to create life, you have to have stable conditions on geological timescales. So a year, 10 years, even 100 years, if you get an extinction level flare, that's rough. Now, and in terms of the planetary magnetic field, you don't want it weak because Mercury has a relatively weak field. It's very poor shielding. You want it relatively strong. Earth has moderate radiation belts, but good shielding. But you don't want it very strong like Jupiter because, yes, you do have good shielding, but it creates its own radiation environment. That's bad news. So the next time you hear a report of a habitability exoplanet, I think you'll be prepared to question that statement. And so thank you. Any questions?
All right, thank you, Stephen. All right, reminder, the question line is on the television. We'll start with, does Mars have a strong enough magnetic field to protect humans like Earth does?
No. Mars is probably one of the worst places to go if you want to stand on the surface of Mars, because not only does it not have, it has a remnant crustal magnetic field, so it doesn't protect you from the cosmic rays, but it also has a very thin atmosphere. And so what happens is, in the Earth's atmosphere, as the cosmic ray comes in, it strikes a water molecule and breaks apart, and then the byproducts of that break apart until you reduce the cosmic ray flux down here on the surface of the Earth. You saw there you have above your head 5 to 15 meters of water, depending on where you live. And that is a very effective shield of cosmic rays. So Mars, terrible place. It's a terrible place to stand on. You see all these pictures of these astronauts that are running around on Mars. They better not do it for very long, because it's actually worse on Mars, on the surface of Mars, than it is on the way to Mars.
Wow. How sure are we that the instrument on Voyager did not malfunction after crossing the heliosphere?
So it looks like it does look like it kind of flatlined, right? And you can't really see it on this plot, but there actually is some variation in that. And the variation is known from shock waves that actually propagated from the sun outward and crossed those two boundaries, and you can actually see it modulate, you actually affect the cosmic ray flux. So we are pretty sure, Alan Cummings, a good friend of mine at Caltech, fairly confident that the Voyager cosmic ray instrument is working properly. And by the way, there's Voyager 2, which produces an equivalent plot.
Very interesting. Let's see, our next question. How can we tell if a star has the right type of magnetic field? Can we measure that field from our own solar system?
And that's a big challenge. The answer is pretty much no. You have to infer a magnetic field from other observations. For one thing is that they can actually see periodicity in stars, and so that kind of suggests that most stars do have a magnetic field.
Is there any benefit of not getting radiation from the sun when you're in interstellar space?
So, yes, there is. What you want to do is avoid a solar flare. A solar flare and a CME, and which was called solar energetic particle events. There was a famous one in 1972, which occurred between, I think, Apollo 16 and Apollo 17, if I'm not correct. And had the astronauts been on the moon during that flare, they were instructed to basically crawl under the LEM, but it's omnidirectional flux by the time it gets to Earth. And they wouldn't have died immediately, but they probably would have died a short time after that.
So on the topic of standing on other places, besides Earth, what other place in the solar system do you think is the best place to stand on?
So I think one of the best places to stand on, and it's totally counterintuitive, is at the bottom of the ocean of Europa. Because although you're in the worst radiation environment in the solar system, outside of right next to the sun, you're shielded by at least 5 kilometers and probably more kilometers of ice. And so, another place would be the ocean in Enceladus. That would be a really good place to be.
Interesting. All right, final question. What about for larger stars like BRA type stars? Wouldn't they avoid this issue of flares as well?
I'm not familiar with the larger stars. The problem with the larger stars is their lifetimes are shorter, and like I said, you really need geological timescale stability, and that's what our sun gives us. The larger O and B stars, of course, they last for hundreds of millions of years, not billions of years, and so that's a real detriment. Again, you see, we fall right in this kind of Goldilocks position.
Cool, thank you. Let's thank our speaker once again. There were plenty of other questions on the text line, and I'm sure Stephen will be happy to answer them. Are you sticking around? All right, so walk right up to him and ask him. But we are going to go on our 10-minute break. So 7:42, we'll come back and do our news segment. And SamuelHartHelio@gmail.com is where you'll email your fancy photos to. Thank you.
All right, everybody. We're going to get back into tonight's scheduled programming. You all find your seats, find a close to the conversation. I'm going to give you the lowdown on what's happened last month with astronomy. All right, for this month's installment of Astronomy in the News, New Moon, who dis, and find out about that. Let's start with what's up in the sky. So this star map. This star map is roughly the middle of the month, September 15th, about 10 p.m. Shouldn't change too much between a couple weeks before, a couple weeks after. But Saturn's at a decent spot around 10 p.m., well placed at 2 p.m., much higher in the sky. This month, look for some deep sky wonders, including Andromeda Galaxy and the Ring Nebula. You can see those pictured here in the bottom left corner. Great things to look at in a dark sky, even binoculars. They stand out very well. They're very pretty. And for some happen successful, they say it is, but I don't know. This is the 10th test flight. It went up and it came down. So it's a successful. Uranus has 29 known satellites. And I don't know if she was on the team, Miriam. And last but not least, some new images from JWST of a protoplanetary park. This Saturday, Medina River Natural Area. Next Saturday. It was on their calendar. They're not necessarily like the sponsors of it, but the Okie-Tex Star Party is happening towards the end of the month. So that'll be a hoot and a holler. It's you want to take a guess where it's at? It's like up by Oklahoma, in the Panhandle of Oklahoma. And then Scopy Planetarium. They're going to have shows on the 12th, the 19th, and the 26th. See the website for their ticket prices and their show times. They have a show.
She would learn about space every chance she got, often looking at the moon and stars, wondering if anyone else was out there looking back at her. She's pursuing a career in planetary science with the hopes of becoming an astrobiologist at NASA, working on podcasts, been featured on online articles, and giving virtual talks is for everyone. Jasmine Singh.
Oh, it's in the song. I think the most important thing is that we need to build public trust. I think it's nice if young girls of color have someone to kind of look up to that looks like them, that is doing what they want to do. And like I said, we are working to bridge the gap between the public and scientists, so that's why I included this meme. Scientists, the public, understanding. This is our goal. Anniversary, and I just talked about how only an hour and 16 minutes have passed on Miller's Planet, which is shocking. And then, sometimes I like to communicate science, but in a fun, meme way. So this was when DART had its impact, and I thought it was a really fitting meme, so I made that, and surprisingly it got a lot of attention. So I like to think that you don't have to be serious 100% of the time to kind of communicate science. You can see I am not serious 100% of the time, but I think that it helps because people kind of see the personality behind the Twitter account and follow. I'd like to think they follow for the personality. I mean, pretty space pictures are a plus, but, we make it fun along the way, too. All right, so I already kind of touched on this, inspiring the next generation, but how did I even do this? Why am I doing this? So we all know what happened in 2020. It was actually when I started sharing my journey on Twitter, but also there was a pandemic. And I just I was a junior in undergrad, and I kind of just wanted to network with people in our fields, because I was moving on out of undergrad. So I figured, okay, let's figure out how to do that. People are doing it online. The world is kind of shut down, so let's do that. And I didn't want to make a LinkedIn. I don't like LinkedIn. So I don't know, maybe there's people out there that also don't like LinkedIn. I really don't. So I was like, how can I connect with people and not have a LinkedIn? Let's do social media. So I just jumped to Twitter for some reason, I don't know. And yeah, from there I just started posting innocently about space and just following people in the field. And 5 years later and 97,000 people, here we are. It's crazy because I had admired for a long time, and now I'm even working with some of them. I don't know, that's just crazy because it's weird how things happen and where this kind of world can take you. We live in such a unique time with online communication, so I took advantage of it. I like to think that I scream about space online, and if you don't know what that means, don't worry, I will show a picture example. And it kind of led to really rapid growth. Like I said, I just hit 97,000 followers today. That's crazy. Don't ask how many of them are bots. I don't know, but it's okay. The number, but I also, I was able to connect with others who viewed me as an inspiration, which is really weird because you're like, I never thought that someone could care, in that regard and see me as someone that they look up to. But I've gotten, and being so open about my journey because, like I said, I don't just tweet about the news. Yes, that is a core part about what I post, but I also just post about my journey. And I have gotten many, many rejections before getting here, standing right in front of you. And I have been, I've been sharing those online because I think that it's important that people see that rejection is normal, failure is normal. So, I hope that it has been meaningful to people, despite whether they're in science or not, is what I'm trying to say. So, finding my style. So, everybody does science communication differently. I literally forgot. I often like about space online. If you follow me or if you have seen my tweets before, they're most likely in all caps. It's just how I do it. I think they get more attention, because it's in your face and they get more likes. So I just keep doing it, and that's what I'm known for. But over time, I started to take it more seriously, in the sense that when I first started in 2020, I had no idea what I was doing. I was just posting cool pictures of me and yeah, I like space, But from, gathering more of a community and also suggestions that I got from people, I started to incorporate them. Some people told me, maybe you should credit your images, which I do that because I think it's really important to credit where you get the images from, especially the people that process them, because that's really difficult. And I know people that process images, Juno images, and it's a lot of work. So it is important to looking at. And also, spoiler alert, NASA has alt text on all of their images, so you can literally just take their alt text and put it on yours, which I do most of the time. It's very well written. It's really easy to include. So it's easy to make your content more accessible, and that's the goal for me. And I'm still, despite me saying all this, I still have a long way to go to learn, what my communication style is like. There you go. So there are some challenges, unfortunately. It is time commitment. I'm not getting paid to do this. This is my own voluntary thing, and I hope that proves that I'm doing this out of my own, passion and love for science. But, I am, at the end of the day, a grad student, a researcher, so that is my primary career goal. I do want to do science communication on the side, but, I have a degree to get, so it is part of my time. There's also haters and trolls. It's a part of being online. You just kind of have to learn to accept it, but I think my best advice is to ignore it. Thankfully, I get enough notifications to where I don't even see the hate comments, so I'm just kind of ignoring them because I literally don't see those comments. So if I'm getting them, I have no idea. But there's a few that I've seen that didn't sit right with me, but you just have to remind yourself that they are jealous. They are not in your position, and you are doing better things than them. So, this is the main goal, is combating misinformation. I think especially in the era of AI, it is very easy to spread misinformation because nobody is checking whether that is real or not. And AI images and videos are getting so good. It's really scary. And not only just AI, but just, read this headline. It's not true. And a lot of science headlines, from mainstream news articles are very sensationalized to kind of grab people's attention. And by doing that, they kind of get away from the point. And there's that gap between the scientists and the people writing those articles. And so, like I said, not all of them are like this, but, the ones that are just, it makes us look less credible. So it's a hard thing. There's so many times. And to bring it back to AI, it's funny because now, when I post pictures, I have so many people at Grok, is this real? Yes, it's real. I literally credited where I got it from. And you can also just ask me, you don't have to get an AI bot to ask if the image is AI, but that's okay. Compared to the person behind the screen, but I like to think that I am still the same person online. Maybe a little exaggerated, but not that much different. When I'm posting in all caps, I am very excited, and that is how I am behind the screen, so it's not that much different. But like I said, I am still working on my kind of image, my communicating style. Like I said, I'm gonna be different. I'm gonna be my own person. And this is also at South Leono. This is at the Europa Clipper launch, which I was very lucky to go to. This was Cocoa Beach, I think is what it's called. The moon's right there. Whatever that was. It was, yes. And this was the launch, so just so you know. So why should you care? Why am I talking about all of this? I think now is the most important time to talk about this, actually, because you've probably seen articles like this. Proposed NASA budget cuts would decimate American scientists, or science, an expert says. This is also a plot of the NASA budget, including the proposed 2026 White House proposal, which would be the lowest, if it goes through, it would be the lowest since 1961. We are in a crisis, a funding crisis, and it is urgent. So, we need public support now more than ever, and that support requires communication. Science is for everyone. I have so many people that follow me that have no clue what I'm talking about. They don't have a background in this stuff. Maybe they took one astronomy class, right? I don't know, but they follow because it's interesting. They follow because of the person behind the screen, they've told me. They follow because of my passion, and I hope it comes through. I hope it's come through tonight. I hope if you choose to look at my tweets online or post or whatever, you see that, because that's my whole point. I wanted my passion to come through, and I wanted to inspire people. Like I said, science is for everyone. I believe there are no barriers in it, and I think, as I do, not explaining science seems to me perverse. When you're in love, you want to tell the world, and I think I did a good job at doing that. All right, if you have to emphasize to people. So yeah, probably Bill Nye. I've also seen him live.
Okay. No, that's, I agree with that. And so he was my commencement speaker, so I got lucky. Love Bill. What's the most impactful interaction that you have had online?
Probably there are, like I said, I've gotten many messages, so it's hard to like remember. But I think I've had people tell me that I've inspired. Because that's what I've been doing, that's what I will continue to do until I am Dr. Singh.
The next question is, recently, how has SciComm overlapped with your research?
Right. So I'm sure Tracy can tell you there's been a lot of milestones for Clipper recently, but I can't share everything, so I have to be careful what I post because there's literally a space that I always love to talk to people about it and like see how my face lights up when I talk about it. And I think, like I said, we live in such a unique time to where we're always online. Pandemic or not, we're always online, right? So I took advantage of that. We can like connect with anyone anywhere in the world now. It's so special. And so I wanted to use it for something good. So I hope that I have done a good job thus far and will continue to do a good job.
All right, let's thank our speaker one more time. This one's supposed, yeah, this one, oh yeah, it does sound better, you're right. Where's the clicker? There it is. Well, for those of you that cannot stay for trivia, I thank you for coming. We will be back again next month on October 1st. Oh, geez. I hate when it's the 1st. Yes, we'll be back October 1st. We'll have two great speakers. One of them is in the room right now. Danielle Bovey will be giving a talk. Yes. And the other one is TBD, but we've got, well, as always, it's going to be a great speaker. So join us same time, same bat channel. And then for those of you that can't stay for trivia, we'll come around as usual with the sheets and pens. Give us about 5 minutes and we'll get rolling at 8:20. So thank you.
So that number right next to the letter on the line, okay? Please write it next to the letter on the line for question 2. Yes. And I want to award a second bonus.
What's your second bonus?
I want you, on the back of the paper, tell me which Voyager went out of the plane of the solar system, or the most out of the plane of the solar system.
All right.
Equatorial plane.
Weird bonus, but all right. I want you to ask what
Ecliptic,
your
sorry. Equator, ecliptic, you know. Right, yeah. It's close enough. Yes, it is. Compared to like how far the spacecraft is above the plane.
All right. Question 3. Picture of the day. What is today's official astronomy picture of the day? The NASA APOD has been publishing daily images since January 1st, 2015. Is it A, 2% moon, B, the Horsehead Nebula, C, Callisto, D, the Africa Nebula, or E, the Pillow Nebula? Who checks their APOD? I don't check APOD. You got. So then, where do you?
Who? Doratus. But it's Dora the Explorer. Oh.
And that means there's 29 other Dorati.
It's true. Yes, that means it's singular because it ends in us. Like alumnus versus alumni.
Ah, Latin.
All right.
Question 5. Astro-Christianity
In Paradise Lost, John Milton describes a shooting star at the beginning of this event that appears to be hurled headlong, flaming from the ethereal sky. Is it A, the fall of man, B, the banishment of Lucifer, C, the second coming of Christ, or D, the battle of Jericho? All right. Question 6.
The TRAPPIST system, the TRAPPIST-1 system, has now how many known planets? Stephen talked about this. This is also how well you know letters. A3, B5, C7, D9. Bonus, write this next to the letter. What is the orbital period of the furthest planet? Closest answer will be awarded 1 point.
Okay, does anybody need a question repeated?
From 1 through 6. 1? All
Got
right.
one. No. Pick 3, my lord. 1 and 3?
All right, well, here's 1.
You're just asking for it. Man, that.
The romance language out of that.
Trial and error.
I mean, you could say the same thing about how do we go from Old English to current English. Oh boy.
All right, everybody good on questions repeated? All right, if you are done, please.
Listen, I haven't graded anybody's yet, but Erica looked at Aaron and mine, and we did horrible. The odds be ever in your favor.
I don't know shit about the sun. Arizona, this institution owns a 1.8 meter telescope. Yeah.
And they want to cancel that one too, so
Yeah.
boo.
Question 3 was name that apod. Oh, I did see this today. It's the Africa Nebula.
Oh, it does look like Africa. Do they bless the rains down there?
God damn it, I was about to do it and you beat me to it.
Right, you know how a book will have a narrator.
Oh, you think John Milton was the narrator?
Yes.
I guess.
Okay. Okay.
It's just you, but.
All right, the TRAPPIST-1 system. How many known planets? That answer is lucky number 7.
Oh, God, I said.
And the orbital period of the furthest planet is only 19 days. And Erica reminded us it's because this system has been viewed with the transit method, which means they're going pretty zippy around there. Pretty zippy. So there you go. All right, the bonus.
And the bonus that goes in the bonus section because it's the proper bonus question. Solar Dynamics Observatory. SDO.
Woo! And now my favorite part of the evening. Time for us to give out prizes. All right, our third place prize tonight, which once again is the Tyler Nordgren calendar, which beautiful posters and how many NASA stickers? 4 NASA meatball stickers. The Starmaster. Congrats on second place. Yeah.
I have to bring it up. Oh, yeah. So, yeah, just like Neil deGrasse Tyson, the only thing I do is planetary.
There you go. All right. Where are we? We are at the end of the session. We will see you all next time on October 1st. Thank you all really so much for coming. I hope you had a great time. If you didn't, email Sam Hart at samuel.hart. But seriously, please sign up for our email list. So Blue Star, SWERI, and UTSA for supporting us. And have a good night. Get home safe, everyone.